Hello everyone. In this lecture we want to talk about instantaneous rate of change in particular. I think in the past we said that if you have the graph of a function y equals f of x, for example, and if there is 2 points on this graph and you connect these 2 points with a straight line, then that line is called a secant line. That's what we said before. And to find the slope of this secant line, we always use rise over run. And if these 2 points P and Q have x coordinates such as A, okay, and A plus H, where H is that increment from A to H, then the change in x, basically, or the run, would be actually equal to H. So this H is actually the same as the same old delta x we used to talk about. So delta x and delta y would be the change in y, which is right there. And the change in y would be f at a plus h minus f at a, which is the change in the y coordinates of the 2 points P and Q. So what we're saying here is that the slope of the secant is rise over run, which is delta y over delta x. But delta y is changing y and delta x is changing x. And we said that changing x, if we use this notation of x coordinate point P to be A and x coordinate point Q to be A plus H, then the amount of change in x is A plus H minus A, which is actually H, the same increment. So the denominator is going to be H. That is the run, basically. This is the run, which is equal to H. And the rise is actually equal to delta y, which is changing y. So from f at a up to f at a plus h would be f at a plus h minus f at a. So it's just a different, perhaps, notation, but nothing, complicated here. The numerator is the rise, the denominator is the run, the numerator is changing y, the denominator is changing x, and we know that h is not equal to 0, of course. Okay, so this is the slope of the secant, of course. And we said that the slope of secant is also known as average rate of change between the 2 points P and Q. Now, if you want to find the instantaneous rate of change, if you want to estimate instantaneous rate of change, that point Q becomes very, very close to point P, such that these 2 points become almost one single point. So the point Q becomes very close to point P. As a result, the secant line starts rotating and it becomes very, very close to a tangent line. A tangent line is a line that touches a curve at only one single point. So that secant line becomes extremely close to a tangent line, basically, because the 2 points P and Q are extremely, unimaginably very close to one another. And in that case, we can actually find the average rate of change using the same formula. But because 2 points are extremely close to one another, we can claim that we have approximated the slope of the tangent line at point P. Okay? So there's an example here. It says a dead branch breaks off a tree located at the top of an 80-meter high cliff. So we have a very, very tall cliff, and that's 80 meters above the ground. And there is a dead branch which breaks off a tree, and it starts falling. After time t in seconds, it has fallen distance d in meters, where d of t, that's function notation f of x, equals 80 minus 5t squared, and t is between 0 and 4 seconds, obviously, because after 4 seconds, that dead branch, which is doing a free fall, is going to hit the ground. So it takes 4 seconds for that branch to hit the ground. And within that 0 to 4 seconds, we have the equation of the distance that this branch has fallen, given by the equation 80 minus 5t squared. And t stands for time in seconds, and d stands for distance in meters. Now it says find the instantaneous rate of change of the distance fallen at t equals 2 seconds. Provide a good estimation. So we need to do a little bit of work here. So they're looking for instantaneous rate of change at t equals 2. Okay, so we are going to say we are going to find actually the average rate of change between 2 points, okay, but two very, very close points. So the first point is going to be t equals 2 because it is required. So the first point, t1, is equal to 2 seconds. The second point, I have to choose it, but I have to choose a point that is very, very close to 2. So I have to choose this increment of h, in other words, and I'm going to select h equals 0.001. I think this is very close. So that means that the second point will be 2.001. So imagine there's 2 points, P and let's say Q, but Q has an X coordinate, or I should say T coordinate, of 2.001, which is very, very, very close to point P. Okay, so if this is the scenario, so what would be delta Y over delta X? That is f at A plus H minus f at A divided by H. So this is going to be, I use d of t for the displacement or distance that the branch falls. When you use that notation, it's going to be d at 2 plus h minus d at 2 divided by h. And because I selected h to be that number, it's going to be d at 2.001 minus d at 2 divided by 0.001. So distance at 2.001, I have to find it by plugging it in the equation. So it's going to be 80 minus 5 times 2.001 squared, okay, minus 80 minus 5 times 2 squared, all over 0.001. Okay, so let's see if we can calculate this with a calculator. So I'm going to go 80 minus 5 times 2.001 squared. Okay, that's 59.97. Then minus 80 and then plus 5 times 4 actually. So it gives me a very small number, which I'm going to write it in the numerator. It is negative 0.020005, okay, all over 0.001. So 0.020005 divided by 0.001, the answer is negative 20.005. So negative 20.005. Okay, that's what we get. Now this answer, let's admit it, it's very, very close to negative 20. So I'm going to say this is approximately negative 20. So what we found was actually the instantaneous rate of change, which is negative 20, I should say approximately equal to negative 20. And the unit of measurement is going to be meters per second, because the numerator is changing the distance that's measured in meters, and the denominator is in the time in seconds. So the unit of measurement for this instantaneous rate of change is going to be meters per second. So the answer is negative 20 meters per second. And this is the answer for this question. Find the instantaneous rate of change of the distance fallen at t equals 2 seconds. Well, that's going to be negative 20 meters per second. That's sort of the speed with which this dead branch was falling. Of course, not at the very beginning, but after 2 seconds. At that single point, 2 seconds before it hits the ground, after 4 seconds, when it's up in the air, it's like doing a free fall kind of thing. At that moment, at that instant, when t is equal to 2 seconds, the instantaneous rate of change, or change of distance with respect to time, or the speed, is like negative 20 meters per second, and the negative means it is falling downwards, of course. Okay, so I hope you understood how we estimate the instantaneous rate of change. Always remember that you have to select a very small increment, h value. You could have selected 0.01 or 0.00001, it doesn't matter. Select something very small, and that way the second point Q will be very close to point P, and your answer, which was negative 20.005, will become very close to actually the instantaneous rate of change. Okay? All right, so I hope you understood the formula, and you understood the concept, and we will talk about this topic more in future. Thank you for your attention.